Hey y'all, so we are back. We are done with the video stuff, although I'm sure that's still gonna pop up in a lot of the things we do. But now we're moving on to MSP, which is the audio side of Max. And what is MSP? It's a lot like everything else we've been doing. It's a lot like Jitter. It's a lot like vanilla Max, but there are some differences with it. So this one's just going to show you some of the basics of like what different kinds of waveforms and what some of the basic objects are, and then we'll get into building stuff into some of the other tutorials. Um, so MSP, just to start it off, probably some of the most common objects you're going to use, and you've probably already seen me even use this, is this easy DAC object. And this is the most, or not the most important thing, but it's an important thing, is this tilde. So every jitter object we had JIT dot, and then whatever the object was. Anything that's a predominantly MSP object or audio-based object is going to have a tilde at the end of the object. So when I hit enter here, should have turned off my notifications. There we go. So we have this easy DAC object here, and it's a GUI object, which is not true of every MSP object, but the basics of it. What that stands for is easy, as in easy to do DAC, digital to analog conversion. Basically, any sounds we're making on our computer, this is our sound output. These are basically, we'll go to our MacBook Pro or whatever computer you're using, speakers. This is channel 1 and channel 2, so your left and right stereo. So we just feed stuff into there and sound will come out. One thing that's important to know is if you go to options, audio status, this will show you just your audio settings. If you're on Windows, you might want to play around with the drivers. You'll probably have to do a few different options, but you can look at what your output device and your input device is. So you can see here, like I have a display monitor here. I could choose that as my output, but I'm just going with the MacBook Pro speakers. And in order for audio to work, you have to turn it on. And you can see when I did that, this turned on right here, the icon changed. Also down here is another way we could turn it on and off. Or on this easy DAC object, you could just click on that with the patch locked. So this is almost like, I mean, there's going to be times we use Metro, but think of this almost as like the Q Metro that drives your JIT World or your JIT Movie. You won't hear anything unless this is on, and all the other MSP objects won't turn on unless your audio is on. So even if you're not hearing anything, like you don't have anything hooked up to this, some of these other objects won't even function unless your audio is processing is currently on. So another object we could look at is cycle tilde. And this is a sinusoidal oscillator. It's an oscillator. It's recreating like vibrations of how sound works. In this case, it's like a sine wave. And we can give it the frequency as our argument. So 440 hertz. We could translate these frequency hertz into notes if we wanted. This is just basically a pure tonal sound. That the higher it is, the higher the sound is, the lower it is, the lower the pitch of it is. And this is jumping ahead a little bit, but well, just to pull it out, if I pull out here, you can see I have a yellow patch cord. So like how Jitter has a green patch cord, this yellow one means an audio signal is coming out of it. And to show you that whole on-off thing, if I hook it up right here, we don't hear anything because it's not on. And I'm going to add one more thing just to jump ahead of this a little. I'm going to add a multiply tilde. And I'm going to say 0.15. And you can do basic math on an audio signal. In this case, what we're going to use this as is our volume, our gain control, just because if you're listening to this on headphone speakers or whatnot, just purely putting that sound in is going to be pretty loud. So I'm going to go ahead, turn that on, hook that up here. And even that's pretty loud. So I'm just going to maybe even lower this a little bit. But you can get the sense that like we get this kind of sound. And I could also give it a float. And if I typed in like 100, it's almost imperceptible. Now it's kind of a lower tone. Low, but still, if I went up to cover your ears for this one, 700. So sorry about that. It's kind of hard to teach this on a video recording without making sounds that are really annoying to listen to. But you can see that basically this is the hertz, or if you want to think of it, the frequency. And there are a couple of other objects that are similar to this. We could also have a saw, which would be a sawtooth wave for oscillator. We have triangle. We could do square, which is not a square, it's a rectangle. That's right. And if I hook up each of these, you can see the saw has a much more like grating, kind of like buzzy sound. Triangle's probably pretty similar. Actually, almost more like the cycle wave there. Rect is. So you can see it's like, maybe it's like, it's the timbre, or the timbre, I guess is how you say it, of like the different kind of audio quality to it. And we can actually visualize these. One way we can do that is with the, what is the object called? Oscilloscope. Can I spell it? Let's see. Oh, it's with the, it's called a scope object. It just takes the last part. So I'm going to set the range it can visualize, which is, I think, -0.5 to 0.5. And I need a range value there. And I don't need the comma. And then the last thing I need is, I believe, how many samples we're viewing at a given moment. Is there anything I'm missing? I might need a gain object. So as before I had used this multiplication, I could also get rid of this. And let me just check here. Maybe it was 5 to -5. So I just had too high of a frequency, I think. Maybe if I set this to 440. I'm just going to grab some reason. Just pulling this from the example patch because for some reason it seems to be behaving a little differently. There we go. So you can see that we have this kind of sine wave right here. And you can see that we're even getting the shape of the wave, the size of it based on the gain right here. And to show you why this is basically the way the vibrations are moving through this. So that's why we're hearing that sound quality. And if I switched it to saw, you can see that we have like a sawtooth kind of like edge to it, almost like the blades of a saw. But what we're seeing is we're seeing the value ramp up and then dropping and then ramp up and then dropping. And a triangle is a little different. we see it actually go up and down and up and down. And it's like a sine wave, except instead of curving at the edges, it's just a sharp bank. And rect is more of like a pulse, like it's on, off, like 0, 1, 0, 1. And that's what's giving these things these different qualities of sound. And you can see I can just kind of manipulate it a little like that. And then also just so you get a sense of this, I'm gonna start this really low. So don't. And another object we can use if we don't want to mess around with the gain is the, the plot object. Ooh, not that. Or maybe it is that, but I need to set it a certain way. And you can see there's lots of examples of how people use it. So I think I can just steal this one. And what's nice about this is we don't have to worry about what the gain is coming out of it. We can just hook it straight up here. And we can see the shape of the wave. And what's also fun about all this is we can also use these to get like actual numerical values out of this. So there's an object called, because right now I could make a float and I can't hook it up because it's an MSP signal. Even though it might have a numerical value behind it, we have to convert it. And we can do that with an object called Snapshot, and we give it how many milliseconds it should update. So every 2 milliseconds get the current value. I think I need it to be a float. And you can see we're oscillating between -1 and 1, -1 and 1. And at this speed, it's like bouncing up and like we're getting that kind of like, it's like moving pretty quickly. So we can't actually see it that well, but if I lower this down to 0.2, which we wouldn't be able to hear as a sound, we could actually use this to control something like the rate in JIT movie or whatnot. So not only does these objects have to be used for sound, they can also be used as like a control parameter for how we want to manipulate something, and it would give it a certain quality. An example of that is the rect, where if you wanted something to kind of toggle on and off really fast, you see it going back and forth. Maybe I'll go change it to 1. So you could have this be like a pulse, like turn on, turn off, turn on, turn off, turn on, turn off. And there's another object I hadn't looked at, which can be kind of fun, is rand, which is just random. This would be like white noise. And I think it's gonna sound kind of like static. And what it is literally kind of just random. It's almost like Perlin noise. You can see like that. So you can get like much, and like that would actually be a great one to use with Snapshot. If I go down to a lower value, it's going to go to a value, and then come down and then go up or go down more at different speeds. So we could even use this as kind of like, when we've been using the random number generator, it's almost more like a drunk, but it's a really smooth drunk. Again, it's like Perlin noise to a certain extent. So this can be a really nice thing to use to control stuff. And then going on top of all of that, I'm going to move this down. We can start to add and combine these things to get different interesting sounds as well. So if I wanted to look at, what if I wanted to combine a saw wave with a rect wave? I could say multiply tilde, set this to 440. And now we have a pretty interestingly shaped wave that's going to change how it sounds. So let's actually try hooking this up here a little. And it's still pretty annoying, but just to simplify this, I'll bring that down for a second. Right now they're very in sync with each other, but what if we offset them? Like what if this was 430? Now we're getting more of like a drone sound. So there's actually more complexity to this sound. And if we put the numbers close together, or we put them really close together, that's how we get these kind of more complex kind of drone sounds. And I haven't even tried this yet. What if we added a little bit of randomness to it too? I guess we could even do things like divide. And now I'm just kind of messing around. I can just use, I mean, I'm not gonna lie, I'm not so well versed in sound stuff that I can get into the math behind this, but I can just play with the math to just see what kind of shapes I get, what kind of sounds I get. And I wonder if there's even like modulo tilde, and output the remainder. Maybe that's more interesting. Maybe I'll just add this in here. Anyway, I kind of lost myself there. That's basically just kind of the intro to MSP. We have these audio signals. We'll also look into like how we can like, I guess it's even like play with this a tiny bit. Is there, I guess I could bring an audio just straight over from here. If you ever need to just bring an audio sample in that you want to play with. See, I have this drum loop. And this is kind of like the JIP playlist. I haven't tried this before, but what happens if we multiply the signal of a song? So it's subtle, but you can see this is kind of where people start building filters, where they start building kind of different things to process an audio song. And I'm sure there's complex mathematical equations that we can use to discern what that is. But we're just going to use pre-built stuff that Max offers up, so we don't have to do that math ourselves. Anyway, the next few tutorials are going to show you how to mess around with audio files more. But we'll come back to some of this stuff later on and learn about how we can make more kind of drone and our own kind of generative instruments from this and whatnot. So enjoy, and yeah, email me if you have any questions.